Okay, so you have to remember that the sign delta always shows a change, like delta v is the change in the velocity and delta t is the change in the time. Now the drive unit for acceleration is meters per second square. Another example we have from the book. Over here, the velocity of a motor car moving along a road increases from 10 meters per second to 50 meters per second. So two different velocities are given in 8 seconds. We have to find the average acceleration. So VI initial velocity was 10 meters per second and the final velocity was 50 meters per second. And the time taken is 8 seconds. We have to find out the acceleration. Now, putting the formula for the acceleration which we have learned, delta V, that is change of velocity, is equal to Vf minus Vi. So, average acceleration is equal to rate of change of velocity, or delta V is equal to Vf minus Vi upon the change of time, delta t. So, 50 minus 10 upon 8. So, we have got 40 upon 8, and that becomes 5 meters per second square. So the average acceleration over here is 5 meters per second square. The calculation is really easy. You just have to observe it carefully. Then we have got another example. In this, a conversion is involved, so you have to observe it really carefully. We have got a car moving with uniform acceleration that attains a velocity of 70 kilometers per hour in 5 minutes. You have to find the acceleration. Now, we have seen that the car has started from rest. Many times it is not mentioned, but it is obvious. So the initial velocity is 0. And the final velocity that is attained. The word attains means it shows that in the beginning it was not the same. So in the beginning it was 0. And the attained velocity, the final velocity is 72 kilometers per hour. And we know that kilometers and hours are not the SI unit. So we have to convert them into the SI units, that is the meters per second. So for that, we are going to multiply 72 into 1000 to convert kilometers into meters, and divide with the 3600 to convert hours into seconds. Observe it very carefully. So multiplying this, we get the answer 20 meters per second, and that's the final velocity in the SI unit. Now the time taken was delta t 5 minutes. Again, minute is not a unit, so we are going to convert this one also. So 5 will be multiplied with 60. Only 60 because we have to convert minute into seconds. So we get 300 seconds. So we have to find the acceleration. Now putting the formula, A is equal to Vf minus Vi upon delta t. That becomes 20 minus 0, that was initial velocity, divided by 300, and the answer is 20 upon 300, and that's equal to 0.066 meters per second. The calculation is easy, but you need to practice it thoroughly. Now today's assignment is that you have to define what is acceleration. Then you have to compare between the scalar quantities and the vector quantities by forming a T-chart. You can re-watch the video if you have got any confusion. And you have to do the problem sums from the book, page number 41, 44. And the sums are 3.1, 3.3, 3.4, 3.5, 3.6, 3.7. They are really easy. They are all easy sums, so you need to just be keen to observe the example and the conversion methodologies. If you find any difficulty, you can ask. Jazakallahu khair.